Hey, welcome to Build an AI. I'm Nia, your AI learning guide. Let's get into it.
Welcome to this explainer. Today, we're going to break down the exact pipeline professional developers use to consume REST APIs without, completely losing their minds. We are moving way beyond the amateur habit of just firing off a fetch call, crossing our fingers, and hoping the right data comes back. It's time to look at the real mechanics of handling data the right way. You know that feeling, right? You're building an application, everything is going perfectly in your local environment, and then bam. The screen goes completely blank, and you get that massive, dreaded, red, cannot read properties of undefined error. Well, you are definitely not alone. This is the universal pain point of relying on raw JSON and messy trial and error in your codebase. Real-world API responses are often huge, they're deeply nested, and they are packed with a ton of data you simply don't need. Accessing them blindly, that is exactly how your apps crash. So let's explore a structured approach that cures this exact problem. Here's our roadmap for today. We're going to follow the literal journey of a data request step by step, starting with the API contract, placing the perfect order, catching network errors, safe data extraction, building a stable view model, and tying it all into a 3-layer architecture. Let's dive in. Okay, Section 1, the API contract. It's time to stop treating APIs as magic URLs. Consuming a public API is honestly exactly like going to a restaurant. The API documentation, that's your menu. It tells you what's available, how to order it, and exactly what each dish includes. The endpoint is the specific dish you decide to order, and the JSON response is the actual food the waiter brings to your table. Reading the docs gives you a strict contract. It explicitly tells you what you need to send over, what you're going to get in return, and the specific errors you can expect if you ask for something that, well, doesn't exist. Moving right along to Section 2, placing the perfect order. Before you even think about writing a single line of code, you've got to step through this systematic template to find exactly what your UI needs. First, identify your specific requirements. If you're rendering a character card from, say, the Rick and Morty API, do you need the name, the image, and the status? Write that down. Second, find the resource and endpoint in the docs that actually delivers that data. Third, identify what query parameters you need to filter it. And fourth, always check the expected JSON response shape. Are they sending you an object, an array? You really need to anticipate the shape before you write any logic. Now, when you're building out that query, here's a massive pitfall. Manual string concatenation is a total anti-pattern because it immediately breaks on special characters. Let's say a user searches for a name with spaces or an ampersand, like Jose and Morty. A manual string will just create an invalid URL and completely break your request. Instead, the pro pattern is to use JavaScript's built-in URLSearchParams. It safely and automatically handles all that tricky character encoding for you, so your query strings are always perfectly formatted. All right, Section 3, catching real network errors, because things will inevitably break. This is an incredibly common gotcha. Native fetch has a really sneaky hidden danger. It literally treats a 404 not found or a 500 server error as a total success. Native fetch only throws a real error if there's a literal network failure, like, say, your Wi-Fi drops. This means you might accidentally try to parse an HTML error page as if it were valid JSON data, which causes massive bugs down the line. And that is exactly why professionals always use a wrapper function, usually called something like fetch.json, that manually checks if response.ok is false. If it is, it intentionally throws a proper error with the HTTP status code attached, so your app can actually catch it and react appropriately. Which brings us to Section 4, safe data extraction methods, digging into the JSON. Okay, the waiter has delivered the JSON dish, but digging into nested data blindly is exactly how apps crash. To protect ourselves, we rely on optional chaining. Plain dot notation is just way too fragile. If you ask for a character's origin name, and that specific character doesn't happen to have an origin field in the database, plain dot notation crashes your whole app. Optional chaining safely navigates these nested JSON trees by literally asking, hey, does this level exist, at each step. If a field is missing, it simply and safely returns undefined rather than throwing a fatal error. Now, once optional chaining safely hands us an undefined, we usually want to provide a fallback default. But you have to be really careful here. Never use the logical OR operator for this. It's too aggressive and will overwrite valid zeros or empty strings because it considers them falsy. Think about it. If an API says a character has 0 episodes, logical OR sees that 0, thinks it's false, and overwrites that valid data with your fallback. No way. Always rely on Nullish coalescing. It is incredibly strict and only replaces a value if it is specifically null or undefined, preserving your valid empty strings or zeros. Section 5. Building the stable view model. This is a real game changer. We have safely extracted the data, right? But we must never, ever pass that raw, unpredictable JSON directly into our UI components. We need an intermediate step called the view model. A view model is a simplified object that you shape specifically for what your UI needs to render. It acts as a total decoupling layer. By creating a view model, your UI only has to speak one, totally stable language. So if the backend API completely changes its nested structure tomorrow, your UI doesn't care. It is completely insulated. To build this view model effectively, we use data transformation functions. And when you do this, it's perfectly safe to destructure flat fields at the top level of the JSON response, things like ID, name, or status. But actually, scratch that if you're dealing with nested data. Avoid deep destructuring on nested objects at all costs. It's incredibly fragile and will easily crash if a parent node happens to be null. For those deeply nested fields, you want to use small, pure helper functions that utilize our optional chaining and nullish coalescing. That guarantees a safe, deterministic output every single time. Finally, Section 6, the 3-layer architecture. Let's put the whole shebang together. What's really interesting here is how we combine all these techniques into a fully modular codebase. Breaking monolithic functions into these 3 clean layers is the mark of a pro. First, the services layer handles the fetching. It talks to the network and knows absolutely nothing about the DOM. Second, the transform layer maps the raw JSON into our view model using defaults. It never makes network requests. And finally, the UI layer handles rendering. It never maps data, it just trusts the view model it receives. This precise separation means if you have a UI bug, you know for sure it can't be breaking your network layer, making debugging incredibly easy. Before you ship any API integration, you need to run it against this robustness checklist. Validate empty inputs. Never fire a request if the search bar is blank. Guard against the API returning an empty or missing results array. Ensure your view model provides solid defaults for missing fields. And always translate technical errors into human-readable messages. A truly robust application defensively handles all these edge cases seamlessly. The result? The user only ever sees helpful states, a loading spinner, the success data, or a friendly error message, instead of a terrifying stack trace. So take a hard look at your own code today and ask yourself this final question. Are your UI components rendering raw JSON, or are they safely protected by a structured view model? Implementing this pipeline is literally the quickest way to elevate your development skills and stop those random crashes in their tracks. Think about what other structural fragilities might be hiding in your code base right now. Keep building securely, and we'll see you in the next explainer.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.